All right, this is example 5. It did say 4, so you can cross that out, make that 5. The first 4 examples were all about uninhabited growth. And now we are finally, the last 3 have uninhabited decay. So iodine 131 is a radioactive material. So this is just the name of it. This 131 doesn't have anything to do with the problem. I'm not using this number. This is the name of this radioactive material, is iodine 131. It decays according to the function, and you have A of T equals A naught E to the negative 0.087 T, where A naught is the initial amount present, and A is the amount present at time T in days. So time T in days. A is the present amount. Assume that a scientist has a sample of 100 grams of iodine 131. So what is the decay rate? So still same thing. You take this decimal and you move it 2 spots. So you can say this one of 2 ways. You can either say 8.7% decay, which is what we have essentially been doing on all of these, right? We've been doing 6% growth. We said here 2% growth. So you can say 8.7% decay, or you can just put negative 8.7%. You either need the negative or you need the word decay. Wants to know how much iodine is left after 9 days. Well, if we have a sample of 100, this is my A naught. So plug in. Now 9 is my T. So I have A of T equals 100 E to the negative 0.087 times 9. All right, we get 45.7. And we are in unit of grams here. When will 70 grams of iodine 131 be left? So this is now my A of T. So we will have 70 equals 100 E to the 0.087 T. Wants to know when we're solving for T. We need to get this exponent by itself. And we will do that by dividing over 100. 70 divided by 100 is 0.7. So I will use the decimal because it stops when you divide the 2. Right? If you do 70 divided by 100, it's a nice 0.7, it ends. If it repeats, you can't use the decimal, you've got to convert it to a fraction. Equals E to the negative 0.087 T. I'm solving for a variable in the exponent position, so I need to get rid of this. And so the opposite of an exponent with a base E is to take the natural log. So I've got the natural log of 0.7 equals, now this comes down, negative 0.087 T. And so I will divide both sides by that negative 0.087. So T equals the natural log 0.7 divided by negative 0.087, which is about what? Okay, so about 4.1, and we're in unit of days right here. So when I have growth, it really wants to know a lot of times, when's it going to double? When you have decay, the big question is, when is it going to have a half-life? So if I start with 100, it wants to know, when are we going to be, that's such an ugly 5. When is it going to be at 50? So get your exponent by itself. So we'll divide that 100 over, which gives me 0.5. To get rid of that e, we're going to take both sides to the natural log. Cancels that out. Just move this up a little bit. So I'm going to get the natural log of 0.5, or natural log of a half, which again should make sense. When I double, this was 2 equals e whatever. So when it's a half-life, it's 0.5 or a half equals e to whatever power. So the natural log of 0.5 equals negative 0.087t. So then divide by 0.078, or negative 0.087. So both sides. So t equals the natural log of 0.5 divided by negative 0.087, which is going to be about what? So should take longer than 4.1, because at 4.1 we had 70 left. So it's going to take about 7.97. So really close to 8 days.